Okay, sorry about that. I didn't mean to, but I accidentally paused the video. So here we go. So now I just need to multiply those two numbers. So I take 2.200 times 7.10. I'm going to get an answer. So my answer is 15.62 times 10 to the negative fourth. Okay, now looking at this answer here, we need to make sure this is in correct sign to notation. It's supposed to only have one number in front of the decimal, but right now it has two, okay? So I know that this decimal has to be moved back here. So I know it's gonna end up being 1.562 times 10 to the something, but when I moved this back, it changed this exponent as well. It's no longer to the negative fourth to make it be the same number. So I'm going to have to change it. Okay, so what did I just do? I made the number smaller, but it was bigger. So this is going to turn into a negative 3. Okay, now let me prove it to you. Kind of forget what you're doing. So if this was a negative 4, remember its real number, the real number that matches it, is this number going back to the negative 4. So 1, 2, 3, 4. That's the real number, is 0.001562. That's the real number. So if I change it to 1.5, I move that decimal up. Now what is this number? Hop it back 3. 1, 2, 3. Okay, so I still have those two zeros. Whereas if I had left it as that negative 4, that would maybe hop it back more and I'd have more zeros than the original number had. So if you change a negative exponent and you have to hop it back on a negative exponent, it actually makes it less negative, okay? So what is our true answer here, because it got all kind of messy, is 1.562 times 10 to the negative 3. Okay. Now let's do the next problem. So a little different when you do division. So that was multiplication. When you do division, you're gonna divide your numerical values. So these are our numerical values here. We're gonna divide those numbers first. So 4.245 divided by 2.9, and we're gonna get an answer. And then it says subtract the exponent. So it's gonna be times 10 to the subtract the exponent. So 4 minus 3. So what is 4 minus a minus 3? Because I'm subtracting a negative number. What happens when the two negatives come together? Remember, two negatives make a positive. So it's going to be whatever this is, this divided by this, times 10 to the 4 plus 3, which is 7. Okay, so let's figure that out. So we have 4.245 divided by 2.9. Get 1.46. So where am I going to keep? I got a lot of numbers this time. So if you're looking at your answers, I had one with 4 or one with 3 decimals and one with 1. We're going to keep just 1 then. Okay, so I'm going to round that up. That 6 rounds up to 4 to a 5. So I'm going to keep 1.5. So I have 1.5 times 10 to the what? 4 plus 3, which is 7. And this one actually worked out really nice. This one already has only one number that isn't 0 in front of the decimal, so that's already correct. That's done. Okay, so now that was all the scientific notation stuff. Now we actually need to do some light calculations. So this is like what you actually had to learn how to do, just you kind of needed to know how to do that kind of stuff to understand this, okay? So first off, we haven't done metrics yet. We're gonna do that later in the year. So I'm gonna mark out the nanometers because you actually need it to be in meters for this calculation to work. And I'm just gonna go ahead and change it to meters, which is 6.50 times 10 to the negative 7 meters. Okay, so I'm just gonna change that nanometers one into the one we actually need in meters because y'all don't know how to do that change yet. All right, so it says the brilliant red color seen in fireworks are due to the emission of light with wavelengths around 650 nanometers, which is 6.5 times 10 to the negative 7 meters, when strontium salts such as strontium nitrate and strontium carbonate are heated. Calculate the frequency of red light or calculate the frequency of red light of this wavelength. Okay, so we have this formula here. This is the formula. And c is always this number. C is the speed of light. Light travels at 3.00 times 10 to the 8th meters per second. That's how fast all light travels. To get your answer of C, you multiply by this, which is wavelength. So literally the size of a wave. Remember when I have a wave, it goes like this. A wavelength is from the top to the other top, so from crest to crest. Okay, so when we measure that, like literally measure the wavelength, that's what it is in meters there, times V, which is the frequency. And frequency, remember, is how many times per second the wave passes. If I multiply those two things together, a wave's length and a wave's frequency, it will equal to the speed of light, which is 3.00 times 10 to the 8th. So I kind of just need to rearrange this formula until it works for what I'm solving for, okay? So I'm gonna put it in. This is my formula. C equals wavelength times V. And C is always that number. That doesn't change. That's just a given number. So I'm going to go ahead and put that in. 3.00 times 10 to the 8th meters per second. There we go. And that is equal to wavelength, which we know. This is the wavelength in meters. So 6.50 times 10 to the negative 7th meters. And then times V. So times the unknown V. This is what we don't know. That's what we're searching for. It says calculate the frequency. V is frequency. I don't know what it is. So how do I get V by itself so I can figure out how to solve for V? What I do is I divide off the wavelength that's attached to it, because remember it's being multiplied. So when I want to move it away, so V is alone, you got to do the opposite of what's being done to it. So right now it's being multiplied, so I have to divide it off. So I divide off 6.50 times 10 to the negative 7th meters, and when that's done, this reduces to 1 or cancels, and whatever I do to one side I have to do to the other. So I did it over here, so now I have to divide this side by 6.50 times 10 to the negative 7 meters. Okay, so now this, so 3.00 times 10 to the 8 meters per second divided by 6.50 times 10 to the negative 7 meters will give me V equals V. All right, so now we got to use our dividing rules. We just did it up here. We're going to use our dividing rules to figure out the answer. So remember, in our dividing rules, you divide the numerical numbers. So we're going to divide 3 divided by 6.50. I'm going to rewrite it over here. So I'm going to take 3 divided by 6.50. And then it's going to equal that scientific notation number, but it says we're going to subtract the exponents. So it's going to end up being times 10 to the, what's the subtracted exponent? So we have 8 minus a negative 7. So 8 minus a negative 7, which really, when those minuses are next to each other, it becomes a positive, like that. So now we solve for it. Okay, so get my calculator, and we have 3 divided by 6.5. And we get 0.46. So again, well, actually both of them technically have 2 decimals, so we're going to keep 2 decimals. So 0.46. So the answer is 0.46 times 10 to the, what's 8 plus 7? So that'd be 15. Okay, now this is the answer in meters. Meters cancels, and it just leaves you with 1 over seconds, which is also second to the negative 1. So that's our unit, second to the negative 1. Over here, sorry, second to the negative 1. But we need to fix our scientific notation. Remember, only one number can be in front of the decimal, and this has 2. Well, actually it has no numbers in front of the decimal. So I need to move it to here. So my new answer would be 4.6 times 10, but that affected my exponent. It can't be 15 anymore. That wouldn't make the numbers comparable. So let's see. If I had to make the number, it was smaller, I made it bigger. This is telling me to hop it this way 15 times. Now it has less to hop, so it's going to be a 14. So again, I just kind of think my way through it. Again, you can always solve it out to see if you're right.